All right, so we're going to wrap up 3-2 today. These last couple examples. And these are tying, adding, subtracting, multiplying into the story or situational problems. And they also add in kind of the aspect of analyzing the function, sort of answering different questions about finding maximum values, that kind of thing. So it just really ties together a lot of stuff we've been doing into these application or story type problems. So here we've got Carolina says she makes wind chimes to sell at a local market. Okay. As she produces a greater number of wind chimes, she can lower the price per unit, which makes sense. You know, you're making more of something, you can buy the materials in bulk, so it's going to cost you less, and so on. So it says this function, the 48 minus 2x, relates the price v to the number produced x. Okay, and the cost c of making x wind chimes can be represented by this function. So this is the price. This is what she's going to charge for them. This is the cost it charges or it costs for her to make them. So we have two different functions, v and c. Okay, so what we've got here is it says how many wind chimes should she sell to maximize her profit based off these functions. So we got a couple things going on here. First off, there's a few things that are kind of hard to read here, but the way a company calculates profit is your profit is equal to your revenue minus your cost. In other words, the money coming in minus the money going out. You know, the money you're getting in by selling the wind chimes minus the cost of you to produce the wind chimes, which makes sense. You know, that's how you calculate how much money you're making. Also, your revenue is going to be whatever price you charge for them times however many you sell. So what they're doing here is they're kind of setting up the equation that you're going to set up with these, and then we're going to figure out how to answer this question. So our profit, which I'm just going to call P, or we can call P of X, I guess would make the most sense, is going to be the revenue, which is the price of a unit times however many she sells. So the price of a unit is this function, this 48 minus 2x. And the number of units sold is X, because that's what they tell us. So it's selling X wind chimes. So this represents the revenue, the price of a unit times however many units you sell. And then from that, we're going to subtract the cost. And the cost is this expression, the 12x plus 64. And so what this problem is getting at is we created an expression basically just based on what was given to us with the functions they gave us, the formula that's given to us, and we write out an expression. So now it says how many wind chimes should she sell each week to maximize her profit? So really what we want to do is figure out the maximum points of this. We can absolutely simplify this. So we can go ahead and distribute this out. So we'd have like 48 x, and we'd have minus 2x squared. Okay. And then from that, we'd subtract these two values. So we did our multiplying like we just recently learned. Now we're going to do subtracting, which remember this negative goes to both. So if we were to write this in standard form, this is going to be our lead term, this minus 2x squared. Then we have a 48x minus a 12x, so that's going to be 36x. And then we're going to have minus 64. So this is kind of our simplified function for the profit. And now that we have that, we can use that to answer this question. If we graph this, we can look for the maximum point of it and be able to answer our question. So let me type this in my calculator. Obviously, you can use decimals too. So if we put this function in and we graph it, we can see what we're working with. So I have my window already kind of weird because I think I did a different problem, but let's just start from standard. So on standard zoom, it's probably going to look like a straight line because it's pretty, yeah. So now we do know this is going to be a quadratic, meaning we know it's going to go up and come down. So we definitely need to go up higher. So I'm going to go ahead and make my Y max like 100. I'm just going to see how does that look. How does that look if I make it go a lot higher? Okay, so now we're seeing that peak. And actually, we technically don't need to go any further, but we can if we want to. You know, if we want to see all the way so we can see this full curve, we can make our X max bigger. So we can make our X max like 20. That should show the whole curve now. But the point we care about, since we're trying to maximize profit, is this spot. This is when the profit is the highest. So now if we do our finding our maximum, so maximum, and then we go left bound and right bound and guess. This will give us that when she sells basically 9 wind chimes, she's going to make $98. So one of the big takeaways from this problem is being able to interpret what's going on. So 9 chimes is going to give her the best amount or the most profit. So that's what we're going to write here. We're going to say 9 wind chimes gives $98 profit. And that'd be her best case scenario. So if Carolina's trying to figure out what should she do, based off all the information we're given, she should make 9 of them, take them in, sell them, and that's going to get her the most money based off all the information we have. All right. Now the little try it problem here basically says same scenario, but what if the cost is this now? So the only thing they're changing now is the cost. They're changing this value. So if we think about that, none of this is going to change. This problem is going to be the exact same up to here. So I'm going to actually write what we had there. We had the 48x minus the 2x squared. But now instead of subtracting 12x plus 64, we're going to subtract 4x plus 42. And now we're just going to look at how does that change things. So, maybe she found a different place to buy her materials, so change the cost. Maybe it's a little cheaper now. So let's see how this changes things. We're still looking for the new maximum profit. So in this case, again, our lead term is going to be this minus 2x squared. 48 minus the 4x is going to be 44x. And then we're going to have minus 42. So, we got a little bit different function now, just because the cost was different. And so now we can take this function, type it in, and we can see how it's different. If it's more profit, less profit, it should be more profit because this is a cheaper cost, which is going to make your profit better. So if we graph this one, we see that it goes up considerably higher. We can see the same thing. Again, we're going to want to make our Y max go bigger. I'm going to change it to like 200. And okay, so that's perfect. So now we can see that point, and just like before, we can find that point. So we find our maximum value, and enter, and guess. So in this case, it's 11 wind chimes yields $200. Pretty good. So best case scenario now is 11 wind chimes, and that yields a $200 profit. Okay. So the idea here is being able to create a function, simplify the function, and then analyze or answer whatever question they're asking. Are they asking for a maximum value, a minimum value? Are they asking for zeros? All those kind of things we've been sort of working on all year. All right. So now they follow up this question on the next page with taking the Carolinas wind chimes problem. So I think they're using, so this is the first one. This is like the A one that we had. And they're saying they're going to compare it to some guy who's selling flower pots, or girl, I guess I don't know, whoever Kio is, or Kaio, selling X flower pots, and this one gives us a function for this. Okay, so at this point, they're asking us to do two things. Basically, we're going to compare the two people's businesses, her wind chimes and the flower pots. So part A says, find the y-intercept of each function, and who would lose more money if neither person sold any items. So the y-intercept is when you sell 0 things. So if we look at this graph, this crosses somewhere down here. And specifically, we remember what that was. We can go look it up. So remember this function? When you put 0 in here, you're going to get negative 64 out. Meaning, if you sold 0 wind chimes, you're $64 in the hole. So for Carolina, we could say that 0 chimes yields minus $64. So she's $64 in the hole if she sells nothing. Kio or Kaio, whatever, on the other hand, sells 0. So we could put this in a calculator if we wanted to, but we actually don't really need to, because if you notice, if you put 0 right here, you're going to get 0 times this is still going to be 0 times this is still going to be 0. We really don't have to work anything out here. 0 flower pots is going to yield a $0 profit. So the case here is doesn't make or lose any money. If he doesn't sell any, doesn't make or lose anything. So I don't know if these are stolen pots he's working with here, because you should have, normally in a scenario, you would lose money here because you would have paid something to get these pots, but maybe he got them donated or he stole some or whatever, and he's selling them. So in this case, the question is, who would lose more money? The answer would be Carolina. She loses $64. He loses nothing. The next one says, interpret the end behavior of these functions. So with Carolina's, this end behavior, so we don't really care about this end behavior because you're not going to sell negative wind chimes. But the idea is, as you sell more and more wind chimes, what happens? She starts losing more and more money for whatever reason. So in this case, as she sells more wind chimes, she begins to lose money just based off her prices and costs. That just doesn't seem to work out. So in this case, for Carolina, I'd say as x goes to infinity, y goes to negative infinity. which is bad. That means that she should not just make as many wind chimes as possible because she's going to lose money. Now with this one, let's go ahead and graph this one just so we can see the end behavior. We can also simplify it, but I tend to find graphing is just the quicker way to go about these. So we can type it in factored form like this, which is fine. And then we go look at the graph, we can see what happens with this function. So this one also, as you go towards selling infinite flower pots, does start heading down towards negative infinity. So in both cases, it's kind of a lose-lose scenario. There's no just sell them forever type thing going on here. You're going to lose money if you just make as many as possible. So same exact scenario for Keo or Kaio here. Okay. So both people, as they make more and more and more pots or wind chimes, they lose money once they hit a certain point. All right. The last piece today is this little try one. It says compare the profit functions of two additional market sellers by the graph of F and this equation. So you're going to see problems like this in the assignment today. So they're saying F is this function that's graphed. G is a different function where they just give you the equation. And they want you to do the same thing here. Compare their y-intercepts and compare their end behavior. So basically we have this F function and we have this G function. So let's go ahead and find both their y-intercepts, both their end behaviors. So let's start with the graphed one because that one's usually the easiest. So this looks like a y-intercept at 0, 0. Okay, so in this case, the y-intercept, 0, 0. And then end behavior, in this case, is as x goes to infinity, so as you go this way, y also goes to infinity. So this would be a case where if whatever this person was selling, we don't know, we don't have all the details here, but if this was something, you'd want to sell as many as possible. As soon as you get to like about 5 here, you are constantly making more and more profit. So, if you could make infinite, you should make infinite. But basically, this person should make as many as possible because of their end behavior. Also, this would be the scenario where if they make none, they lose no money. So, so far, this looks like definitely the best business scenario. And then G, we've got the function, so we can do the same thing we did here and type it in and take a look at it. So we have x plus 1, and we have 5 minus x. So we can graph and look at that. Let's go ahead and go standard window because this is pretty squished in there. Okay, perfect. So first things first, y-intercept, this value, I can get it off my table. So at 0, this graph's at 5. So this is a particularly weird one, especially if this was about selling something. If this person sells nothing, they're still $5 ahead. Again, that's a pretty weird scenario. It's almost like someone donated them some money to get their business started, and they still have money left over after they've got their materials and everything. So kind of a weird scenario, but it is possible. And then as far as end behavior goes, this is another one. As you start making more and more and more of your thing, you start losing money. There's a sweet spot here of your maximum profit, but as you make too many, you are going to start losing money. So this is just like the first two, where y goes to negative infinity in these cases. So again, it's just about analyzing the functions, being able to kind of describe what's going on, and finding maximums, finding y-intercepts, finding end behavior, all this kind of stuff about your functions.